The working principle of a cooling tower is when hot water from the cooling tower enters the cooling tower and flows from above. Water pressure pushes the water dividers to rotate and sprinkle evenly on the grill surface. Welcome to the Ice-Cool Ice Machine. Today, let's learn about the ice-making process and principle of the Ice-Cool 20-ton ice machine system. Ice-Cool Ice Cube production line, 20 tons a day includes equipment: a water filtration system, a 20-ton ice machine, and a cold storage for ice storage. First, we will talk about the working principle of Ice-Cool industrial ice machine. Ice-making process. When the Ice-Cool ice machine operates, the refrigeration compressor begins to suck in refrigerant gas, then compress the gas up to a high pressure of 15 kilograms and a temperature higher than 100 degrees Celsius. On the compressor's push line, there is a valve. Direction: the purpose is so that when the ice machine system stops running, the gas pressure will not push back to the compressor, thereby reducing the pressure caused to the compressor when operating. The hot gas is then pushed to the condenser to reduce the temperature. In the condenser, gas and gaseous form exchanges heat with cooling water to reduce the gas temperature and change phase from the gas state to the liquid gas state. At the inlet and outlet of the condenser, there are stop valves installed. The purpose is to lock these two valves when cleaning the condenser to prevent external environmental factors from affecting the system. Cold. After receiving heat from the hot gas, water will move into the cooling tower to be cooled. Water pressure pushes the water dividers to rotate and sprinkle evenly on the grill surface. Water moves down through the leaves of the radiator grill, forming thin films of water. The air will be sucked back up through the radiator in contact with the water and carried away with hot steam to the outside environment. Water exposed to air will decrease its temperature quickly. After cooling, the water is sucked back into the condenser by the pump to continue the refrigerant cooling cycle. After being cooled in the heat exchanger to an average temperature of about 35 degrees Celsius, the gas will flow into the high-pressure tank. In the Ice-Cool ice machine's high-pressure tank, gas will be on the upper layer, liquid gas will be on the lower layer of the tank. Liquid gas from the high-pressure tank is moved through the filter. The function of the filter is to filter dirt, residue, and water vapor in liquid gas. In the Ice-Cool ice machine, the inlet and outlet of the filter will have two valves that open and close. When we need to replace the filter, or clean the filter, close this valve to isolate the filter from the system. Gas continues to enter the heat exchanger. The heat exchanger helps exchange heat to reduce the temperature of liquid gas before entering the mortar, thereby increasing the cooling capacity of the gas. Gas continues through the fluid-level solenoid valve. The fluid-level solenoid has the function of opening and closing as required by the control system, helping to control the gas flow entering the throttle valve. Once this throttle has achieved optimal performance, it should not be adjusted. If you tighten or open it a little, the ice-making process will change greatly. Ice may slip or there will be excess gas. After being sprayed from the two expansion valves, the gas will continue to flow into the ice bowl to continue cooling the stainless steel ice-making pipes. Gas is still liquid, but its temperature will drop to a very deep temperature, dropping from 40 degrees Celsius to more than -20 degrees Celsius. The deep negative temperature of the gas exchanges heat with the water flowing in the tube. The temperature difference causes the gas to absorb and boil to form gas. The Ice-Cool ice cube machine contains both gas and a certain amount of viscosity. The purpose of the oil is to make the gas boil more. To measure this amount of gas and control the gas supply process, the Ice-Cool ice machine uses an external contact electric float valve. In the float valve tank, there will be a gas float. When the liquid gas rises, the gas float rises to a certain point. When the stone mortar has enough gas, the float rises to the upper contact. The PLC control system will signal the fluid supply solenoid valve to close. There is a stop valve below and above the float valve. When we need to check, clean, or replace the float, we close these two valves, isolating the float valve from the stone mortar. After the refrigerant gas exchanges heat with the ice tube in the ice bowl of the Ice-Cool ice machine, the gas boils and the gas vapor will be sucked into the compressor. During the boiling process, a lot of gas rises up, and a refrigeration compressor is an air compressor. When the gas vapor condenses into liquid gas and then returns to the compressor, hydraulic shock will occur to the compressor, causing damage to the refrigeration compressor. Therefore, before returning to the compressor, the gas needs to pass through the liquid separator. The gas flow is high and the gas temperature is low. If it condenses into liquid gas, it will flow to the bottom of the tank and back into the stone. At the bottom of this small road, there is a throttle valve used to adjust the flow of viscosity in the stone mortar to the compressor along the gas suction line. On the way to the compressor, the gas passes through the heat exchanger mentioned at the beginning of the video, exchanging heat with liquid gas. The purpose is to increase the gas temperature before returning to the compressor. Avoid gas condensing into liquid gas, causing problems. The gas continues to go to the filter to filter out dirt, then is sucked back to the compressor of the ice-cool ice machine. The closed circulation process of the medium continues. Water filtration process. To produce pure ice, water source testing is most important to ensure quality. Normally, there are two main sources of water used, well water and local water. To ensure that the water source meets standards, the water needs to go through a filtration and disinfection process to achieve ideal water quality for ice production. After being pumped, water will enter the water filter. This filter will include 2 fine filters and 3 coarse filters. In the first stage, the water will enter the fine filter core to filter out all dirt and other impurities mixed in the water. The water will then continue to pass through 3 coarse filter columns in turn. Each basic filter column will contain different types of filter materials with specific uses, such as filter gravel located at the bottom of the column helps the filter system not be clogged with suspensions, and also acts as a support for the material layers above. Charcoal absorbs impurities, chemicals, dissolved organic substances in water, decolorizes and deodorizes water. Manganese sand removes oil and heavy metals such as iron and copper. In addition to the basic materials above, there are many other materials to help purify water. After the water has passed through the 3 main filter columns, it will continue to go through the fine filter again to remove all impurities before being sent to the tank. Clean water source helps ensure high purity ice quality, transparent and beautiful ice, in case the water source is contaminated with salinity, alum or limestone. ice-cool's team of engineers will advise on how to handle it effectively. Water from the tank will continue to enter the water tank of the ice-cool ice machine. When the water is full, the float valve will signal to close the water supply line, and the water will be pumped to the top of the stone mortar. The amount of water tends to decrease during the formation of stone tubes. Therefore, the float valve will open to supply water when the water level drops. In the stone mortar, there will be many water dividers to regulate the flow of water into the stone mortar. When water flows through this water divider, it will pass through 2 water grooves, forming 2 whirlpools that help disperse the water into a curtain that flows into the stone tube. The water curtains will come into contact with the ice tube that has been cooled by gas, with a temperature of more than 20 degrees Celsius. The layer of water continuously flowing around the tube wall will form an ice film. This process continues to make the ice layer gradually thicker, up to form a stone tube. After ice is formed, water tends to rise and impact the water float, signaling to stop pumping water and begin the defrosting process. Defrost process. The main ice discharge valve opens to directly supply hot gas at a temperature of over 100 degrees Celsius to the stone mortar screen and into the mortar. 2 auxiliary defrost valves open to mix the gas from the compressor and the gas from the tank into the mortar. The ice tube will begin to increase the heat to melt the water. The ice in contact with the tube wall will melt until the size of the ice cube is smaller than the size of the ice tube, at which point the ice will become loose and easily slide down. At this time, water is supplied back to the stone mill to increase defrosting efficiency. Stone cutting process. Falling stones are cut into ice cubes of suitable sizes by the stone cutting tray to suit the customer's needs. The rock will fall into the ice cone and then go down to the rock bucket. The fish cutting process continues until all the stones in the tube have been cut. After that, the ice-making process begins again and continues to make a new batch of ice. All processes for making ice, defrosting, and cutting ice take place completely automatically. Cold storage. After being automatically produced and packaged, ice cubes will be put into cold storage to preserve ice cubes. The cold storage floor should be lined with plastic floor mats to isolate the cold storage floor from the ice. Create ventilation and cleanliness during use. Cold storage for storing ice cubes is usually set at an optimal temperature of about -5 degrees Celsius. This temperature helps the ice become harder, firmer, and older. Stones do not stick together. In places with hot seasons and high temperatures, cold storage for ice cubes is a solution to help improve quality, reduce losses due to weather, and be more proactive in the production process. In addition, cold storage is also an option to help customers proactively produce and store large amounts of ice when there is a scheduled power outage or machine maintenance plan, or before holidays when ice demand increases too high. Need pre-production. Thank you for watching. Hopefully the video above will help you understand more about the operating principle of the ice maker. See you again in the next videos. Sincerely,